Hello. This video is for lesson 7 of chapter 2, so we're doing lesson 2.7. It is titled Decimal Operations and Equations with Decimals, where our objective is to solve equations involving decimals. Our vocabulary for this lesson, or actually review vocabulary, is absolute value, solving an equation, and decimal. So, hibernation. When a chipmunk hibernates, its heart rate decreases, its body temperature drops, and the chipmunk loses weight as its stored body fat is converted to energy. In example 5, you'll see how to use an equation with decimals to describe a chipmunk's weight loss during hibernation. So you already know how to perform operations with positive decimals. However, just as there are negative integers, such as -2, there are also negative decimals, such as -2.5. The number line below shows several positive and negative decimals. So first of all, let's remember that on a number line, everything to the right of 0 is positive, and everything to the left is negative. So over here on the positive side, we have -0.5 and -1.75. So the thing to remember about decimals is decimals are on the number line between the whole numbers, or between integers to be exact. So like 0, 1, 2, 3, those are whole numbers. And then whenever we take whole numbers opposite, such as -1, -2, and -3, then we have the group of integers. So all of these numbers that we see down here, and with their corresponding locations on the number line, these are integers. Decimals are what we find in between the integers, such as 0.5. Well, 0.5, and 5 is in the tenths place, so this is 5/10, which can be simplified to 1/2, so we see that that is dead center right in between 0 and 1. And then 1.75, well, this tells us that we have one whole, so we at least have up to 1 on the number line. Then 75, and the 5 is in the 100ths place, so we would say this is 75 100ths. And 75 100ths will simplify to 3/4, and you can see that this point on the number line is 3/4 of the way from 1 going towards 2. And then you have numbers down on the negative side that are decimals, such as -1.3. 0.3 is 3/10, which is pretty much close to 1/3. So this point is about 1/3 of the way between from -1 to -2. So as we move this way, if we moved it just a little bit more, it would become like -1.5. And then we see the -2.5. Well, it sits right in between -2 and -3, so that's because it's right in the middle, because 5/10 is equivalent to 1/2. And the number out here preceding the decimal is a -2 because it's less than. And I know we want to say greater than, but actually it's the absolute value is greater than 2. So trying to think of a way to word that best, but you can see that the number itself, the absolute value gets greater. That means it gets further away from 0 as we move to the left. But it actually, as it goes to the left, this number might seem to be increasing. Well, its absolute value is increasing because it's getting further from 0, but actually its value is becoming less and less and less as we move it to the left on the number line. So the point is to understand that we do have negative decimal numbers as well as we have negative positive decimals. To understand that we have negative decimals numbers just as there are positive decimal numbers. There we go. So the rules for performing operations with decimals are the same as you learned for integers in chapter 1. And that is that whenever we're adding or subtracting decimals, we pretty much do it the same way as whenever we're adding or subtracting integers. Here it says to find the sum of -2.9 and -6.5. Well, we are adding, so the rule for adding is that if they have the same sign, then we actually go ahead and add them together, and we end up with 9.4. And since the sign for both of these is negative, that means that the sum is just going to get more negative, and so we still have a negative sign here. The important thing is that whenever we add negatives, that if we do -2.9, we have to line the decimals up. Well, in this case, they both only have one value. They only have the tenths place in here, so if we were to line them up, they'd still kind of line up naturally, you might say, if we just did 2 digits over 2 digits, the decimals happen to line up. So, but be sure to line your decimals up in this case, and then we'd also have it in the answer. So 9 and 5 is 14. We carry the 1. 6 plus 2 plus 1 is 9. And both of these are negative, so our sum would be negative as well. Yeah, this one's going to be a great example for what I was saying about lining them up. And that is to say, find the difference between negative 25.38 minus, thus the word difference, negative 42.734. Well, first rewrite the difference as a sum. So we're going to keep this negative 25.38. We're going to keep that. We're going to change the sign from subtraction to addition. And then we're going to take the opposite of the value that follows. Well, the value that follows is negative 42.734. So we're going to use a positive 42.734. Then use the rule for adding numbers with different signs. Well, if they have different signs, then we're going to subtract the one that has the lower absolute value from the one that has the greater absolute value. And in this case, 25 and 42, we can kind of look at the whole numbers to see which one's the whole number portion of the integer portion of it, the part preceding the decimal, to find out which one has the greatest absolute value. And that is going to be the 42.734. So we're going to take 42.734. And I need to line the decimals up, as I was saying earlier. And we're going to subtract from that 25.38. And we're subtracting. The reason why is because they have different signs, right? We're adding together two numbers. One's a negative, one's a positive. So we're going to subtract them. The number we start with is the one with the greater absolute value, and the one we're subtracting from it is the one with the lower absolute value. So as you can see right here what they're stating, this here is it's all about finding the absolute value of each number. And let's go ahead and throw a place holding 0 in there so we have the same number of decimals. And our decimal and our answer is going to be in the same position. We are subtracting, so it's 7 minus 4, or 4 minus 0 is 4. I'm already looking over here. And then I'm going to need to borrow one, right? And this is going to be 13 because I'm borrowing one from this, and that's going to be 6. So 13 minus 8 should be, what is that? Well, the difference between 13 and 8 is what? 5, right? It takes 5 to get from 8 to 13. So that would be 5. And then 6 minus 3 is going to be 3. And then 2 minus 5, well, I'm going to need to borrow again. So let's make this 12, and I'll borrow one from there. That's a 3. Now 12 minus 5 is 7, because 7 plus 5 is 12. And 3 minus 2 is 1. And now we end up with the 17.354. And the question becomes, is it positive or negative? Well, notice that the 42.734 has a greater absolute value than negative 25.38. So 42.734 is positive, so therefore our answer is positive as well. So same process that we used for adding subtracting integers, we use for decimals as well. So here's a couple, we'll do a couple of these here. Both these are the same sign, right? So we can go ahead and add them together. Let's line those decimals up. And we're actually going to add them because they're the same sign. Decimal down here. And so 3 plus 2 is 5, and 4 plus 1 is 5. And since they're both negative, we would make that answer negative as well. So this is going to be a negative 5.5. On the next one, we have 10.57 plus a negative 6.89. Well, in this case, they are different signs, so we're actually going to subtract. And 10.57 has a greater absolute value than negative 6.89. So I'm going to subtract 6.89. And we are finding the difference of these because they are different signs and we're adding them. So 17 minus 9. Well, 17 minus 10 is 7, so that must be 8, right? And we borrowed. That was 17, right? Had to borrow. So then 14 minus 8 is, what is it, 6? So we have 6 there. And we had to borrow also to get from over to there, right? So this would have been 9. This goes to a 9. That goes to a 0. So I end up with 9 minus 6 is 3. And I need my decimal, keep my decimals lined up. And the 10 has a greater absolute value than the negative 6.89. So the 10 is positive. So in this case, our answer is going to be positive as well. So it's going to be positive 3.68. On the next one here, it's subtraction. This would be a lot easier if we were to go ahead and make it a sum instead of a difference. That is to say, make it addition instead of subtraction. So let's go at 9.817, change the sign, and then take the opposite of the number that follows. So that's going to be a positive 1.49. Now we need to add these together, and the trick is going to be to keep those decimals lined up. And so I'll line up my decimals, and now I have 1.49. Let's throw a place holding 0 on there. And we are indeed adding these. So 7, I want my decimal over here. And 10, carry the 1, 12, 13, carry the 1, 10, 11. So we end up with 11.307. And they are both indeed positive numbers. So the answer is going to be positive as well. Looking at the next one, multiplying and dividing. So we covered addition and subtraction. Now we're going to look at multiplication and division of positive and negative decimals. So perform the indicated operation. So for A, it is a negative times a positive, and they are different signs. So down here we have the negative times positive, same problem. And a positive times a negative, or a negative times a positive, equals a negative. If they are different signs, then the product, or the result of multiplying, which is a product, that's negative as well. On B, we have a negative times a negative. Here we see that there, negative times negative, and it equals a positive. And that brings up the rule that if they are both the same signs and we're multiplying or dividing, then the product is also positive. On C, it is division. We have a negative being divided by a negative, and it produces a positive. Note that if they are the same sign, then the quotient is positive. The quotient is the result of dividing. And then finally, on D, we have a positive divided by a negative. Here the signs are different. And if the signs are different, then the answer, that is to say the quotient, since it's dividing, is going to be negative as well. And that kind of brings us to the story of the Western town story that I've used for years to kind of help remember this rule. If you were building a town, you want good people to come to your town. And if you wouldn't want bad people to come to your town. And if good people left your town, well, that would be a bad thing. You don't want good people leaving your town. But if a bad guy left your town, you'd be more than thrilled to have a bad guy leave your town. So with that said, we're going to go ahead and list good guys. We're going to call it good guy is a plus. And a bad guy is a negative sign. And we're going to say that coming to town, O-W-N, we'll say that's a good thing, and we'll use a plus for that, and we'll say leaving town. Yep, yeah, there we go. I'm on the right track. Leaving town. We'll say that that is a negative sign. So if we have a good guy, all right, come to town, well, that's a good thing. If we have a good guy leave town, well, that's a bad thing. If we have a bad guy come to town, that's a bad thing. But if a bad guy were to leave town, then that's a good thing. So don't know if you want to use that memory device or not. That's one way to remember it. The good guy comes to town, that's a good thing. Good guy leaves town, bad thing. Bad guy comes to town, bad thing. Bad guy leaves town, good thing. So one way to remember that a positive times a positive is a positive. A negative times a negative is a positive. So the signs are the same. Here we have these two here. This one and this one. Same sign. With the same sign, then that's going to be a positive. Unlike this situation here, where we have different signs. I'll just do DIFF for different. If we have different signs, then it produces a negative result. That's for multiplication and division. So let's go ahead and look at this one here. Find the product or the quotient. So that's also going to bring up thing about, I'm suspecting my students often use calculators to do this. So lining up the decimal isn't that much of a deal, but lining up the decimal is an addition subtraction. It's a little bit different for multiplication. So let's go ahead and look at how that's done here. So if I have 3.1 and 6.8, if I were multiplying, if I pretend the decimal's not even there, I would look at this as 31 times 68, right? So I would write it out, and I'm not even going to worry about the placement of the decimal for now. I'll worry about that after I'm done. So using the algorithm for multiplying numbers, 8 times 1 is 8, and 8 times 3 is 24, and 6 times 1 is 6, and 6 times 3 is 18. And then I would go ahead and add these together, right? And I'd end up with 8, and 6 plus 4 is 10, carry the 1, 10, 11, carry the 1, and 2. Now, where the decimal goes is determined by how many places there are after the decimal here. So here we have one number after the decimal, and here we have one number after the decimal here. We add these values together, which is going to be 2. So I need 2 decimal places. So I'm going to start right here, go over 1, 2, and put the decimal there, and my final answer will be 21.08. And if you think about it, look at this. 3 times 6 is 18, right? And 18 is a little bit more than 21, and that makes sense because you got the 1/10 and the 8/10 being multiplied as well. So it makes sense we'd be a little bit higher than 18. If you got the decimal in the wrong place, had 210.8, you'd be like, okay, something seems off because the 3 times 6 equals 18, and 210 is way further than 18. That can't be right. So, but this is the process for determining where the decimal goes and how to multiply decimal numbers. Now, dividing decimals is a little bit different. Oh, and by the way, that was a positive times negative, right? Yep. So this is actually a negative 21.08. On the next one, dividing decimals is the process for that's a little different. Remember, the first number is what if we got the little box-looking division thing there, first number is what goes into it, so that's 11.41. And then I have 0.7 out here. Now, before we even get started, we're going to, the trick is like, oh, okay, I don't want a decimal out here, so I got to move it over one place there. So I'm going to move it over one place here. And so my decimal is going to go here in my answer. Now, it's not really a trick. What you're doing is you're just multiplying both the values by, you're multiplying by 10 so that this 0.7, so this 0.7 now becomes 7, and that this 11.41 becomes 114.41. Now you're set up to go. So we just move the decimal over one place. And what you do to one, you have to do to the other, but you're basically just multiplying both values by 10. So 7 will go into 1 0 times. 7 will go into 11 once. 1 times 7 is 7. 11 minus 7 is, what is that, 4? Bring down the 4. 7 will go into 44 6 times, right? 6 because we would get 42. And then subtract, and we get 2. Bring down that 1. And now 7 goes into 21 3 times, and that is 21. And we end up with 0, so we're all done. So we end up with 16.3. And this is negative divided by negative, so they are the same sign, so this would be positive. And then on the last one, wow. This one here, I'll show you how to set it up. Chances are you're going to use a calculator on this anyhow. But we have a box here. What goes first is the 15.841. Now here we have the 217. And that's 2.17. Now we need to move the decimal twice, which means we're multiplying by 100. So we're going to move it twice here. Now the decimal in our answer would go here, and we could then go ahead and start our problem. At that point, do I really want to try this? It might take a little time. Let's go ahead. I guess I'll give it a try. 217 will not go into 158. It won't go into 1. It won't go into 15. It will not go into 158. Let me see. 200 into 1,584. 200, 7 times would be 14. Let's try 7, just to give it a try. 7 times 7 is 49. Carry the 4. 7 times 1 is 7, plus 4 is 11. Carry the 1. 7, 14. 7 times 2 is 14, plus 1, 15. And great. This value is less than the 1519 is less than the 1584. So I can do my subtraction there. And so 14 minus 9, I'm borrowing 1 here, 7. 14 minus 9 is 5. And 7 minus 1 is 6. And yeah, I didn't borrow there. So 65, I'm good. I'd stop there, right? This just equals zeros. So 65 is less than 217, so I know I did all right on picking 7 on that. And then I bring down the 1. Chances are this is going to work out nice and even. So 2 will go into 200, will go into 600 3 times. Let's give that a try. 3 times 7 is 21. Carry the 2. 3 times 1 is 3, plus 2 is 5. Yep, this is going to work out nicely. 3 times 2 is 6. End up with 0, so 7.3 is the quotient. And it is a negative divided by a positive, so the signs are different, so this is going to be negative as well. Wow, a lot of stuff in there. So in solving equations with decimals, it's pretty much just the same as the solving equations with integers. So you can use what you know about decimal operations to solve equations involving decimals. So we're going to solve these two equations here. We have x plus 44.7 equals 3.5. The 4.7 is tied to the x through addition. We want to isolate this x, get it by itself. So we're going to subtract the opposite operation, or the inverse operation of addition is subtraction. We're going to subtract the very number we wish to get rid of. And what we do to one side, we're going to do to the other. These two are going to cancel each other out, leaving us with just x, and 3.5 minus 4.7 is negative 1.2. On the second one, we have y minus 6.19. Well, here we could, do they go ahead? Nope, they don't change it to a sum, but they realize that the 6.91 is connected to the y through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of, which is the 6.91. And what we do to one side, we're going to do to the other. And these two are going to cancel each other out because they are opposites, leaving us with just y. And the sum of these two values here is 4.65. So again, just like we done it in the other lessons of solving equations, we used inverse operations to undo and isolate the variables. So it's the same thing here. And remember, you can always plug your answer back in and see. So here, if you believe that your answer were negative 1.2, which is from this problem here, you would just plug it back in and then see, does it make a true statement? And indeed it checks out, so your solution would be correct. Let's just pick a couple of these. I'll pick one addition, one subtraction on this. So let's say x plus 3.8 equals 5.2. So the 3.8 is tied to the x through addition. The opposite operation is subtraction. I'm going to subtract the very number I wish to get rid of, which is 3.8. And what I do to one side, I do to the other. So I'm going to subtract 3.8 from the other side as well. And whenever I do that, these two are going to cancel each other out because they're opposites. Leave me with just x on the left. And then here I need to subtract. Can't take 8 from 2, so I'm going to have to borrow. But I can take 8 from 12, which is going to give me 0.4, or give me 4. I say 0.4 because the decimal is going to go here. And then 4 minus 3 is 1, and it's going to be positive, right? On the next one, let's try 13 here. I kind of like my variables on the left, so I'm going to write that part on the left, t minus 2.75. And then I'm going to put the negative 9.34 on the right, negative 9.34. So the 2.75 is tied to the t through subtraction. The opposite operation is addition. and I'm going to add the very number I wish to get rid of, which is 2.75. And what I do to one side, I am going to do to the other. So I'm going to add 2.75 over here as well. And whenever I do that, these are opposites. They cancel each other out, leaving me with just t on the left. And then I have negative 9.34, and I'm going to add to that a 2.75. So I am adding a negative and a positive number together. So I'm actually going to be subtracting. The one with the greater absolute value is 9.34. So I'm going to subtract from it the lesser absolute value, which is 2.75. And then, remember, keep the decimals lined up. 4 minus 5, can't do that. I'm going to need to borrow 1. So it's going to be 14 minus 5, and that's going to be 9. 2 minus 7, can't do that. I need to borrow again. And so that's going to be 12 minus 7 is going to be, what is that, 5? And then 8 minus 2 is going to be 6. And in this case, the 9.34 had the greater absolute value. So it's negative. So my answer is going to be negative. So we end up with negative 6.59. All right. Moving along, solving using multiplication and division in equations. We need to bear in mind that just like we saw earlier, that if the signs are the same, then it is positive. If the signs are different, then it is negative. So first one here, negative 0.6m equals negative 5.1. We'll rewrite that. The negative 0.6 is tied to the m through multiplication. The opposite operation is division. That's why we see a fraction bar here. Every fraction is a division problem. We're going to divide by the very number we wish to get rid of, which is negative 0.6. And what we do to one side, we have to do to the other. So the negative 0.6's are going to cancel each other out, leaving us with just m. This is a negative divided by a negative, so it's going to be positive. And 5.1 divided by 0.6 is 8.5. On the second example, we have n over 8, negative 8 equals 1.75. Or that is to say, n divided by negative 8 equals 1.75. So the negative 8 is tied to the n through division. The opposite operation is multiplication. So we're going to multiply by the very number we wish to get rid of, which is negative 8. So we have negative 8 times the quantity of n divided by negative 8. Wow, trying to get through this tough sometimes. And what we do to one side, we do to the other. The negative 8 is going to cancel each other, leaving us with just n. And negative 8 times positive 1.75 is going to equal negative 14, because negative times positive is negative. So let's see if we have some examples here. Indeed we do. Let's do 14 and 16. We'll do 14 and 16. So we have 7x equals 40.6. And the 7 is tied to the x through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is 7. And what we do to one side, we're going to do to the other. The 7's are going to cancel each other, leaving us with just x. And then we have 40.6 divided by 7. So let's do 40.6. Divide that by 7. And 7 will go, no need to move any decimals, right? The decimals already moved over. So 7 will not go into 4. 7 will go into 40. What is that? Not 7 times, not 6 times, but 5 times. So that would be 35. And 40 minus 35 is 5. Let's bring down the 6. 7 times 8 is 56, so it'll go in 8 times. So we have our 56 there, and we're at 0. And finally, we see that 58 is our solution. And it should be positive because this is a positive divided by a positive. So same signs, works out that way. Actually, I should do 15. 15 is different signs. 15 is wanting to point out that your answer, you're going to end up, well, let's go ahead and do that. Negative 1.8 u equals 6.3. And we're going to divide because the negative 1.8 is tied to the u through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is 1.8. And what we do to one side, we do to the other. And these will cancel each other out, the negative 1.8, so we end up with just u equals. And this is a positive divided by a negative, so our answer would be negative. And then, yes, I'm going to go ahead and use the calculator here. 6.3 divided by a negative 1.8 equals negative 3.5. All right, already 30 minutes into this video. I didn't want to stack it up. So let's look at 19. It is a division problem. So we have negative 9.1 equals v over negative 5.9. The v is tied to the negative 5.9 by division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 5.9. But what we do to one side, we have to do to the other, 5.9. That's negative. So over here, the negative 5.9 is going to cancel each other, leaving us with just v. And here we have a negative times a negative, so it's going to be a positive. And 5.9 times 9.1 is going to give us 53.69. And that's going to be a positive because the signs are the same. And also 9 times 5 is 45, right? And so this is almost 6, right? This is 5.9 is nearly 6. And 9.1 is pretty much 9. Well, 6 times 9 is 54, right? Well, our answer is almost 54, so 5.369 seems to be a good answer. It seems to make sense. Always make sure your answers seem to make sense. And then we come to the chipmunk. So we can use the chipmunk example to talk about how we would have an equation involving decimals. When a chipmunk hibernates, its weight decreases by about 31 hundredths of a pound. Yeah, 0.31, 31 hundredths of a pound. After hibernation, a chipmunk weighs about 35 100ths of a pound. Find the weight of a chipmunk before hibernation. So we're going to let W represent the chipmunk's weight in pounds before hibernation. Write a verbal model, then use the verbal model to write an equation. So we're going to say that his weight before hibernation minus the weight that he loses during hibernation would be his weight after hibernation. Well, if we set that up, we could have W, because the weight before hibernation is what we don't know, minus the weight that he loses equals the weight that he weighs after hibernation. So the 0.31 is tied to the W through subtraction. The opposite operation is addition. We're going to add the very number we wish to get rid of. And what we do to one side, we have to do to the other. And so these two are opposites. They're going to cancel each other out, leaving us with W. And then the sum of these two values here is, we have here the sum of 0.66. And actually, if I were to think of this, if you were to ask me this question, I'd be like, well, isn't it what he weighed after plus what he lost would be what he had? So I would have just kind of shortcutted this, and I would have just said that his weight before hibernation is the sum of these two, instead of setting it up like this. So all depends upon how you look at the problem. And then for the sake of time, not going to really do this problem here. It says during hibernation, the chipmunk's body temperature drops to 37.4 degrees Fahrenheit, which is 61.2 degrees Fahrenheit below the normal body temperature of the chipmunk. What is a chipmunk's normal temperature? So this is pretty much the same thing as setting up here, okay? All right, with that said, I'm not going to do the checkpoint for sake of time, and we are at guided practice. So complete the copy and complete for vocabulary check. The sum of a positive decimal and a negative decimal has the same sign as the decimal with the greater blank. Well, that should be the greater absolute value. Anytime that we are adding a negative and a positive integer or decimal at that point, that we would actually end up subtracting, and then the answer would have the same sign as the decimal with the greater absolute value. Describe how you would solve the equation negative 7.9x equals 86.9. Well, I do know that I'd have to divide, and I'd have to divide by the negative 7.9. That's going to leave me with x by itself. But what I do to one side, I have to do to the other, so I would end up dividing this by negative 7.9. I'm not going to actually work that out, but I do know that this is going to be a positive divided by a negative, so therefore the answer would be negative. So I do know that whatever x is, it's going to be negative, and it's actually going to be the result of 86.9 divided by negative 7.9. And we've done problems like these through the checkpoints on the other, so for the sake of time, we're pretty long into this now, about a 35-minute video. We're going to go ahead and skip that guided practice for today. So that pretty much covers it for decimal operations and equations with decimals. So be sure to check all this out, and remember that the key thing is that whatever rules that you are applying to integers, it's going to apply to decimals. The important thing is to realize that whenever you're adding decimals or subtracting decimals, you have to keep the decimals lined up. And if you are multiplying and dividing decimals, there's special rules. So if you're multiplying, just pretend the decimals aren't there, and then see how many place values have a decimal, how many numbers are after the decimal, and be sure to move your decimal in your answer. Or in the process of doing division, that you be sure to move the decimal over for each of them, so that, and be sure that your decimal's lined up in your answer up here with what you have here. All right, so that's about it for this activity or for this lesson. Thank you.